surely anything can be done here, right? And look at this diagram. I just drew it for you. Just go make it so, right? No, coding is hard, and it continues to be hard. And code gets bigger and bigger and bigger, but our brains are not getting any bigger, and this is largely a brain exercise.
Hi, everyone. Welcome to Behind the Tech. I'm your host, Kevin Scott, Chief Technology Officer for Microsoft. In this podcast, we're going to get behind the tech. We'll talk with some of the people who've made our modern tech world possible and understand what motivated them to create what they did. So join me to maybe learn a little bit about the history of computing and get a few behind-the-scenes insights into what's happening today. Stick around. In this episode of Behind the Tech, we'll meet Anders Hejlsberg. Anders has always been one of my coding heroes. He built Turbo Pascal at Borland, which is the tool that I use to become a real software engineer. At Borland, he had a long career where he was chief architect of Delphi in addition to the Turbo Pascal tools, and eventually moved over to Microsoft where he helped create C# as the lead language designer, and today spends his time as the core developer on TypeScript. Anders has had a 35-year career building development tools that software developers love, and we're going to learn how he's done that today on Behind the Tech. So, welcome, and thanks for being my first guest on this debut podcast.
Thanks for being willing to experiment.
You were a calculated first choice because, I think I've told you this before, but I learned to program when I was 12 years old. My entry was, BASIC and 6502 assembly language, Z80 assembly language. But the first real programming I ever did was on Turbo Pascal.
Yeah.
I went to a science and technology high school and took intro to CS class, and Turbo Pascal 5.5 was the tool. I don't think I would have chosen a career in computer science if it hadn't been for that sort of confluence of things.
Awesome.
So, in a way, you're responsible for my career.
That's awesome.
The main reason I wanted to have you on the show is this must be the case for a huge number of folks, and we'll get into your journey as an engineer, but what made you decide that you wanted to build programming and development tools? Because that's sort of been your entire career.
Yeah, it has. I've been doing it for more than 35 years now. And it's kind of scary to think back. And it's such a long time ago now, right? I mean, and the world and the industry, well, there wasn't really an industry even, but it was so different. I mean, in the industry, I got started probably in the early 80s, but I got started coding in high school back in the late 70s, probably. I was trying to think back, 78 or 70. Yeah, 78.
And were you the type of tinkerer where you were building little programming languages?
No. So I was born and grew up in Denmark, and I went to a high school outside of Copenhagen, and it was one of the first high schools to offer students access to a computer.
Yep. What was the computer?
That was an old HP 2100, it was called. It had 32K of ferrite core memory. You could literally open it and see the ferrite cores. It was amazing.
Yeah.
Paper tape reader, and then after a while, they got a 14-inch, 1 megabyte hard drive, which was absolutely state-of-the-art.
It must have been huge.
It was enormous. The read-write head on that thing had this gigantic magnet, and, everything was so primitive, you could program it. And we put that poor computer through so much torture, like trying to make music by moving the read-write head on the hard drive, and it would, vibrate the whole table, and it was...
That's great.
Yeah. So that was sort of a very hands-on introduction to computing. And I do remember that you could either program it in assembly code. I think there was a Fortran compiler, but then there was an HP Algol compiler.
Oh, interesting.
And that was actually sort of how I vectored into that branch of programming languages ultimately, because that was the first language I was taught. We didn't have BASIC. There was no BASIC on that computer. Do you know what I mean? So I learned Algol, and this was a very primitive compiler. I mean, it didn't support recursion for
right.
That machine had no stack, so call instructions would just store the return address in the first word, and then return was an indirect jump back to that, right?
I'm probably going to get in trouble for saying it, but better than Fortran or COBOL.
It was still better than Fortran. Yeah. But anyway.
How much were you all influenced by this Scandinavian programming language? So Nicholas Wirth was the designer of the Pascal programming language, and then Modula later.
Yeah.
And
It's funny, in high school, I didn't know anything about any of that. And really, it was just sort of learning by doing. And then I started electrical engineering at the Danish Engineering Academy. There, I met a guy who had just transferred from another school into the Engineering Academy, and we both liked playing cards. And he lost some money. And so I had some IOUs, so I had to get to know him.
Nice.
So I ended up getting involved with him in starting a computer company in Copenhagen. And we had the very first retail store where you could go in and buy a kit computer.
Wow.
We were right at the cusp at that time of microprocessors becoming democratized, the 8080 and the Z80, and like this is when the Sinclair ZX80 started to happen, and there was this British kit computer called a NASCOM, which had a Z80 in it, and I started writing software for that one then, and it came actually with a Microsoft ROM Basic.
That's cool. So what sort of software were you writing?
Well, so first I started writing games. It's funny, I never liked playing games, but I liked writing games.
And were these sort of text-based adventure games?
Yeah, it was like Moonlander and Star Trek and that sort of thing, right?
Nice.
And you could actually buy these books. I think it was like Byte Magazine had these 101 computer games where you could type it all in, right?
Yep. It's great. Like, it was such a great thing.
It was awesome. So I learned a lot. But then I started actually getting into assembler coding and sort of trying to understand more about how the machine worked. And then I got curious about extending the Microsoft ROM Basic, because that ROM Basic, it had to fit into an 8K ROM, right? So there were a bunch of commands it didn't have. There was no renumber command, which was a royal pain in the neck, because if you ran out of num, now you had to like manually go retype every line. But there were some extension points where you could actually sort of hook into the ROM Basic, and because there was an extra slot for EPROMs on the motherboard, I wrote this little 4K ROM Basic extension that gave you renumber and a bunch of other things. So that was sort of like a little plug-in toolkit, right?
And so how old were you then? This is like after university?
Yeah, I was probably 20.
So like very, very early in your career, you are mucking around with your programming tools.
Sure, yep.
And like, is that, just sort of a sensibility thing, or?
I just sort of found it interesting. There are a lot of challenges there, right? And then that interest further got piqued by, now that I've figured out, you could actually extend. I remember, still missing that ALGOL programming language. And I was telling my buddy, maybe I should write a little ALGOL thing that we could play. No, there's this new thing called Pascal. You really should check that out. He was going, so, okay. And then I started looking, this is better. Because, one of the things that Niklaus did consistently through his entire career, he's the creator of Pascal, right? But he was involved with ALGOL, and then later Modular and Operon, and every language got progressively simpler.
Yes.
ALGOL had all these complex, like call by value and call by name, and then Pascal dumped a bunch of that, and then Modular dumped even more of that, and then Operon got even more minimalistic.
Yeah. I remember I've never written a real ALGOL program, but because I was a compiler guy, the ALGOL grammar was all over the place in the early compiler literature. It's so complicated.
It was. So anyway, so then I set to work and wrote this little Pascal. That was effectively the nascent Turbo Pascal, if you will, right? It had a little on-screen editor and a runtime library and a compiler, and it was all squeezed into 12K in a ROM.
What gave you the idea to do that? Because that's sort of a new thing, right? That might have been the first IDE, right?
Yeah, that was probably one of the very first IDEs ever. Yeah, I think.
That's amazing.
Well, UCSD Pascal was on the Apple II, but it was sort of different, and it was a P-code interpreter, and the IDE was not really quite as user-friendly, it was more like a sort of a semi-command line-y IDE-like thing.
And so you wrote this thing was it mostly in assembly?
It was all in Z80 assembly,
Wow.
Yeah. Oh, yeah. No, that was my weapon of choice at the time, right? And then,
so awesome.
And then that grew into a CPM 80. It was obviously, that one was a subset implementation, right? And then that grew into a fuller subset, and then finally a full implementation for CPM 80. At that point, we met the guys. Borland was founded in Denmark. A lot of people don't know that. And we knew the original founders because they had another computer company, and it was a very small industry in Denmark, right? And they were writing some stuff in Pascal MT+, I remember, from Digital Research, that CPM. And that was a horrible Pascal. It was like one of those, like, insert pass one disk in drive A, right? And then it would grind, and then you'd take that out, and then it would write some temporary code, and then you'd insert the code generator disk. And it took an afternoon to compile a small program, right?
And there were like dialects of Pascal that were just like not as nice as Turbo Pascal.
Right. And they were afraid of making extensions, and I was never really afraid of making extensions if they were useful.
Yep.
So these guys, we got actually this implementation. You should check it out. And they didn't believe a word of what we're saying because that's not possible.
I just want to double click on this point again. Coming up with one of the first integrated development environments that you had written in Z80 assembly language at that point in time. That's an unbelievable breakthrough.
I suppose in retrospect, yes. Yeah, I never really thought of it that way, but
it's incredible. It's like the first. Sure. Like, what the heck?
It just seemed like, heck, this is going to be so much better than having to have first load an editor and then load a debugger. Why not just put it all there? I mean, I don't know. I never really...
And especially at the time, because, I mean, again, like more framing. These are not windowed systems, can't have multiple things open at the same time. Like, it's super tedious to switch from one program to another. Right. So, like, having everything in one place is just a huge productivity win.
Totally. The edit, compile, run, debug cycle just shrunk by many orders of magnitude.
Yeah, and I'm embarrassed to say I've like forgotten what was it, F9 to like compile and run, or was it F5?
I don't even remember what it was. I think it was F5. Yeah,
but it was like miraculous.
Or maybe it was F3. But it was great.
Yeah,
there were all sorts of tricks in there. Like the runtime library was the first 12K of the system, and then when producing code, I'd just copy the first 12K into the exe we were producing. There's your runtime library, right? And then then generate code from there on out.
Yep.
And you could compile to memory, and we'd put the code in memory and run it, right? Or the original implementation, you could compile to tape, to floppy tape. And then you could, to the tape recorder interface, right? And then you could load that machine code up because, there was only 64K of memory. It was crazy.
Yeah. So I bought a copy of Turbo Pascal 5.5 out of a catalog called Programmer's Paradise. This is just sort of how you used to buy software. Yes. And so I forked over my $200 or whatever it was.
Oh, no, it wasn't even that much. It was $49, like $49.95.
Yeah, so it was affordable because I was poor, so thank you for making cheap software.
Yeah.
But like it came on like this bundle of 5.25-inch floppy disks that, I sort of fed into my, and I was lucky enough to have
I got to give credit there to the Borland guys, to Philippe and Niels and Mogens and Ola, the original founders of Borland, because what they did, they ended up licensing this Pascal compiler that I had in my small company. And we were selling it for $500 and doing business the way business was normally done for software, right?
Yep.
And then they licensed it. And of course, we never thought to put a minimum price on what they were supposed to sell the product for. And then they come back and go, we're going to sell it for $49.95. Go, what? It's just terrible. It's supposed to sell for 10 times as much. But so they cut the price by 10x, and then they literally sold 4 or 5 orders of magnitude more copies of it, right? That was tremendous.
Yeah, when you think about the life cycle of innovation, it's like not always just about the technical thing.
Right.
Like that wouldn't have been an appropriate environment for students if it had cost $500.
Right. And at the time, it was like, hey, if you only charge $50, why even pirate it? It's worth it just to have the manual that actually tells you how it works, right?
Yeah. So one of the other things that was really good about Turbo Pascal is the manuals were actually quite good. Yeah. How big a push did you have in that?
I had written manuals for the Pascal compiler that we had in our company called Poly Pascal, and it had a pretty extensive manual for the language. The introductory parts were not as great. Those, and Ola, who wrote the documentation, Ola Rasmussen, he did a great job on turning that into something that was really a fun book to read, and so a lot of people were very happy with the documentation as well. Yeah. So it was just sort of a confluence of a bunch of factors that just came together, right? And the right thing at the right time. And the industry was so nascent. That was it.
So going back to your university days, did you have a professor or colleagues or like someone who was really great at the programming languages and compilers part of the curriculum where they sort of lit this aha moment for you?
Not a whole lot, actually. I did electrical engineering because in order to do computer science, you would have had to gone to the university. But I was always more of an engineering sort of focus, and I wasn't necessarily sure that programming was what I wanted to do. Do you know what I mean?
Yep.
And at the school at the time, they had yet to introduce personal computers. So they had the Northern European Computing Center there where you would turn in your stack of punch cards, and then the next day you'd get the printout, which would just be 100 pages that said error, error, error. And then And then you'd have to go back and figure out why it was that, right? And it was horrible. It was like a week-long debug cycle. But then they started getting some Z80 and CP/M-based microcomputers. And by the time I left the university there, they were actually using Turbo Pascal or Poly Pascal, the one that I'd written, in the introductory courses.
Holy crap, that must have been great.
So my professor did allow me to not attend the class. He did give me an A.
Because you read the compiler.
Yes, that's right.
That's great.
Yeah.
I think one of the things that folks may have started to take for granted now is like you sort of jump online, you've got Google, you've got the open source community, you've got YouTube and like all these video resources. So I would argue that it's like much easier now to bootstrap yourself as a programmer, even in sort of esoteric things like how to build a compiler. So how did you get your bootstrap? Like how did you figure out how to do this stuff?
You know, you learn by doing. You learned the hard way, in a sense. I mean, and in retrospect, there were so many things that had I known that, I could have gotten there a lot quicker. A couple of things, I suppose, is one is you couldn't stop me from doing it. I wanted to do it. Someone once talked about how do you get really good at something? Well, it's by putting in the time. There's this talk about the 10,000 hours that you got to put in. And I was like, yep, I definitely put in 10,000 hours in the first 3 years that I did this because I was obsessed. I just had to do it. I didn't care if anyone paid me. It was just the challenge of it was so interesting,
And it probably wasn't 10,000 glorious hours, right? You probably were like, making lots of mistakes.
Absolutely. Yeah, and I didn't know how to write a compiler. But then you started looking at compilers that were written, and since my native language was machine code, I could disassemble other stuff and figure out how that worked, right? And then you gradually learned. But there were still things I didn't know. Even in the first version of Turbo Pascal, I remember all the symbol tables were just stored as linear lists, which of course doesn't scale so well, right?
Yeah.
I mean, and then I remember learning about hash tables, and I was like, holy cow, I got to go home and try this. And then I put it in, I doubled the speed of the compiler, right? I mean, I remember that's one of the first books that I thought was really instrumental for me in understanding a lot of sort of the basic computer science was written by Niklas Wieth called Algorithms Plus Data Structures Equals Programs.
Which is a great book.
Oh my God. It is the most pragmatic computer science book I have ever seen. I was like never into the symbolism and the formal proofs and whatever. I just give me the algorithm, tell me, let me understand how it works, right? And this thing explained how binary trees and binary search and hash tables and how to build a compiler with a scanner and a lexer and a parser. Do you know what I mean? And a code generator and recursion. And oh my God, it was like, I loved that book.
Yeah.
You can go back to it today and it is still super valuable.
And I've always loved books like that. Another good one, Dave Hansen, who used to work at Microsoft Research here, wrote this book called C Interfaces and Implementations. And I like C because it's sort of simple. I mean, it's got a bunch of hair on it, right?
It
that
does.
like makes
it
but like
easy to make mistakes. But
it's easy to make mistakes. Not the most elegant language, but it's simple. Like you can sort of pack all the rules into your head. But this book, C Interfaces and Implementations, was genius because it was a bunch of data structures and sort of approaches to programming that were super pragmatic. They had these very broad applications, and it was almost like teaching C to do crazy object-oriented sort of things that it couldn't
roll your own V-tables.
Yeah.
No, I mean, heck, at Borland, we definitely had lots of systems that were sort of calm, like in, that Windows is largely based on is effectively roll your own V-tables, right? So
at Borland, how did you all get feedback? How did you know you were pushing your product in the right direction?
That's a good question. I mean, I
the cycles were long, right?
They were. I mean, back then there were a lot of trade magazines. You got a lot of feedback through that, through the reviewers,
like
reviewing your
Journal
and Byte magazine and what have you, right? We also had bulletin boards early on, like the old BBSs that we would monitor in our tech support, and so. There were a variety of ways. People would write us letters and send us letters. I got so many letters with suggestions for stuff. So we always had a long list of things we wanted to do. And it was really not a matter of figuring out what to do. It was like a matter of which ones don't we do and sorting it and doing the right ones, And like you mentioned, Turbo Pascal 5.5, that was the release where we introduced object-oriented programming. I do remember, oh my God, that was like the big buzzword of the time. That was sort of like the AI of the 80s, right?
And it was the good implementation. So, like, you must have taken some inspiration from Modula.
Well, Object Pascal was probably the work that Larry Tesler did at Apple. That was definitely an inspiration. Although our first implementation in Turbo Pascal 5.5 was a little bit different. It had some influences from C++ also. And then by the time we got to Delphi, I think we were sort of more true to Object Pascal. There was no difference between object references. You didn't have to use an up arrow to dereference them. And then that made the syntax a lot more gentle on the user, right? It was just foo.bar, not foo up arrow.bar.
Yeah, I remember. So 5.5 was where I learned object-oriented programming. I think I'm sort of lucky because if you got thrown into modern Java, for instance, and that was your playground for object-oriented, it's so complicated now.
It is, but it's also in some ways simpler, right? Because back then, the languages that people used, by and large, did not have garbage collection built in and were very, very not safe, right?
Yes.
I mean, and had minimal runtime checking. In fact, we shipped Turbo Pascal by default with runtime checking turned off because we did better on the benchmarks that way, right? And a lot of reviewers were not smart enough to know to turn it off, and so they were comparing apples to oranges. And we just wanted to make sure that we were always in the running there. Once you introduce garbage collection, then you really sort of up the level of programming styles. You can write in a style where you have much more complex function results, and you don't have to worry about who deallocates this, who owns this memory, who's supposed to get rid of it again, right? And you don't have all of these cycles that you maybe get if you implement with ref counting or whatever you do to keep track of your objects, right? So it made the world a lot simpler in a lot of ways. And then the fact that these languages can be memory safe, that removes a whole bunch of other, I mean, the thing that saved us all at the time was that there was just only so much capacity. There's only so much you can do in 64K. And even though Bill said 640 was going to be enough, there's only so much you can do in 640 also, right? And so that always saved us. It was like the complexity was never big enough that you couldn't get away with it. But once you're in this now, is literally a bottomless pit. And there's so much code. You take so many dependencies. And if you don't have some of these guarantees built into the system, you're going to be spending an awful lot of time just chasing down dumb bugs that really you shouldn't. And that's not the creative process. That is just a waste of time.
Yeah. So I want to get to that, but before we jump into modern type systems, let's talk a little bit about Delphi. So maybe the compiler didn't change all that much, but my God, everything on the front end.
That was sort of a revolution on the IDE side. It's interesting because I worked on a project in between that never went anywhere. It was codenamed Monet at Borland, and it was about building applications visually, which was very sort of, back then everyone was talking about software ICs, and you could just plug and play and draw lines between the inputs and outputs on these different things. And we were building this very advanced set of components that you could just plunk down on a canvas and wire together. And, making Fahrenheit to centigrade converters was super easy, right? But it turned out that making big apps was horrible because you had lines going from everything to everything, and it just didn't scale. But I think in that process, I got a real appreciation for what does work well visually, like designing inputs and GUIs and whatever, right? And GUI was starting to happen. And so there was definitely a need there. And so by the time this Monet thing did not pan out, and we realized it wasn't going to pan out, then we sort of went back to basics and then go, okay, well, let's actually get into the GUI era with this product, right? And there was this thing called Visual Basic out
Correct.
That taught us a lot, but also had a lot of issues. Like it didn't have object orientation. It was interpreter-based. It was generally a frowned-upon language, at least by a lot of people, right? And so we go, we can do this, and we can do it better, right? That was sort of the genesis for Delphi. And then I think in the process of building Delphi, we also realized that, and this I think was Zach Erlock, our program manager, who very astutely realized that you can't just ship a RAD tool. You got to have some angle. And the angle at the time was client-server. And so we actually pivoted it into a client-server tool. And that gave us an inroad into enterprises and companies that were really building real database-connected apps. I mean, I remember competing with PowerBuilder. I don't know if you remember PowerBuilder out there. Yeah. And so that gave us a unique vantage point compared to Visual Basic.
It was sort of an interesting thing. Delphi came out shortly after I graduated from college and I became a real software engineer. And I remember being so grateful for it because I did a bunch of work with it that clients were paying me for, and the tool made me look better than I actually was, right?
Sure.
We had made this transition from, you're building these text-based apps where, like, if you're really fancy, you're sort of blasting ASCII codes into screen buffers. But Windows 95 came out. The onus was on you. Like, it looked slick. It was a pretty operating system.
It was an awesome way to build client apps. It really was. And it had a bunch of fun things in it. Like, I remember the two-way code generator. You could either visually design your form or you could go in and modify the code and then the form would change, right? And the way that making that work was not easy, but once it did work, oh my God, it was so cool, you know?
That must be a gratifying thing. You've been doing this, your entire career, but there's just this, in my mind, a force multiplying effect of building developer tools is you put your development effort into this thing and then it gets into the hands of a huge number of people.
That is the thing that I think, in retrospect has been hugely rewarding is like when you build end user apps, you don't build the same kind of fandom as you do when you're building developer tools because developers, they put in the hours. Do you know what I mean? And they come to really depend on their tools. And they come to truly appreciate what they do. And then they become these ardent fans, and that
almost religious, right?
And that is so rewarding. Throughout my career, that has been so rewarding to go speak at a conference and have all these people come up and tell me how you saved my life, you did this. I mean, people have literally told me that. I mean, it's like guys who were in Russia, and couldn't put bread on the table, learned to program with Turbo Pascal, and literally, this guy's claiming I saved his family's life, know? I mean, and I'm just, God, that is amazing. That is wonderful.
That's really great.
Yeah.
So at the time, you sort of referenced it already, like there was this intense competition amongst commercial entities, companies like Borland and Microsoft and the guys who were building Power Builder, and there were these database language things going around, and literally catalogs full of shrink-wrap software that was just for developers to help them get their job done. And so the big thing that came on the scene right after Delphi was Java. How did that factor into your move from Borland to Microsoft? Because, like, in a way, C#, it seems like an address to Java.
There's an arc there, definitely. But I do remember, I think it was in 95 when Java made its first appearance, right? And this is where the internet was starting to happen, right? And in particularly, I think in the development tool space and programming, there was this collective madness around Java where everyone thought it was over. It was done. There were going to be no more programs. Java was going to take over the whole world. There was a Java fund. Remember the Java fund? Funded by hundreds of millions of dollars whose sole purpose was to just invest in companies that were building their software in Java. As if that would make a difference, right? It was brilliant what Sun did, and I think even they had no idea what they had unleashed there, right? But it was discouraging in many ways because we felt that, yes, that's fantastic for building applets in the browser, but you can't build real apps with this thing. But hey, you know what? There was the shiny object. There was sort of a collective craziness over the Java thing, but there were also things that I thought were interesting. I mean, this whole notion of write once and run everywhere, is even today, it just so happened that it wasn't actually born out by Java. It was born out by JavaScript, right?
Correct.
But which was there already in the browser and ignored for a decade, right?
Yeah, crazy.
It's crazy. We had a JBuilder tool that we built at Borland, which actually was built in Delphi. They started with the Delphi IDE, chopped it down, and then the language service, or they weren't really called language services, at the time, but the mini compiler analyzer used by the IDE to do all of the syntactic highlighting and whatever, that was also written in Delphi. So I got to know Java as a language. And then at the same time, there was sort of a change afoot at Borland. Borland had a bit of an identity crisis, in the sense that everyone was up-leveling how business was done, and it all became a game of platforms. Oracle was databases, Sun was workstations, Microsoft was the OS, and then Office became another platform. And Borland never really got the platform up-leveling. It was always a bunch of separate products, and we tried to bundle them together, but it never really made sense. And the company was so singularly focused on trying to, get a foothold in that business that they started neglecting their developer tools, which was really where the company came from, and a series of management revolving door. And I got more and more disillusioned. And then, of course, Borland ended up going through a bunch of reductions in force, if you will. And we spread a bunch of people into the universe. And a bunch of them went to the Valley, but a lot of them went to Microsoft. And then, of course, they started calling every summer when the weather is nice in Seattle. I'd get a call from Brad Silverberg, who had run R&D at Borland and now was running Windows 95 development. So I would come up and we'd talk. And the first year I wasn't interested. But then eventually it was time. So I joined Microsoft in 96.
And was C# the first thing that you worked on?
No, not at all. There was no C#. There was no .NET at that time. No, I joined to work on Microsoft's Java development toolset.
Oh, interesting.
Yes, and I worked on Visual J++. So at the time, we had a Java development tool, and it was really just our C++ IDE with the C++ compiler taken out and a Java compiler stuck in there, right?
Yep.
That was Visual J++ 1.1, I think. And then we jumped from 1.1 to 6.0 because we realigned all of our RAT tools. VB was at version 6, right? And so it became Visual J++ 6.0, and it had a visual designer. You could design applets and whatever. But then we were also doing stuff that made it a better language for writing Windows apps. And that ended up being very controversial. I have personally read the contract we had with Sun. It was explicitly permitted in there that as long as we ran all the standard tests, we were free to do additional inventions, But that blew up, right?
Yeah.
And literally within 3 months of us shipping Visual J++, our product was enjoined by a judge in San Jose, and we were required to put in a warning dialogue. Warning, you are about to turn on Microsoft proprietary extensions. Are you certain you wish to proceed? Do you know what I mean? And that was just so you could use COM interop.
Right.
That was considered so evil. And I was like, this is crazy. Inside Microsoft at the time, the Java fever, it was all over the industry. And there were literally fractions of groups at Microsoft that believed that it was all going to be Java. We should build a Java OS. It should all just be Java, right? But then that happened, the whole Sun lawsuit and whatever, and that was sort of the genesis for us understanding that, listen, it's really hard to do what's right for your customers by extending someone else's platform, right? We got to build our own that works for what it is that our customers are telling us that they want. That was the genesis of .NET. And of course, we needed a programming language. I so happened to find myself right at the right time at the right place for that, right?
So how fun was that? Is that the first time that you had a blank slate?
Totally. Yeah. I mean, can you imagine the opportunity to have a company like Microsoft put their might behind a programming language that you're going to create? I was flabbergasted that I was given that opportunity. Yeah, sure, I'd proven myself. But there were still a lot of other people at Microsoft who had different ideas about what should be done. And then ultimately, I was the one who was handed the task. So that was wonderful. And we had a great team on that early C# compiler, which originally was written in C++ or C++, actually, because we didn't use all of C++. And
which is a whole other discussion.
Oh, yeah. Yeah, I remember a guy named Peter Goldie wrote the core implementation of the compiler. I wrote the language spec. We had a wonderful design team process that we set up that, to this day still exists, where we used to have 3 meetings a week for 2 hours where we would just do the language design, iterate on it, you know what I mean? And Scott Wiltemuth, our program manager that I worked with for almost a decade, was the PM. So for 4 years, he commuted from Hawaii. We would do our design meetings on a speakerphone with him. It was a great time.
Based on some of the stuff that you've talked about already and just sort of looking at C# and then TypeScript, you're fairly pragmatic when it comes to language design. You're not one of these language designers that's like, oh, let's throw a Hindley-Milner type system in.
I've always been a believer in understanding the problem and feeling the utility of something before I want to go implement it. You know what I mean?
Yeah.
I have to believe in it.
Yep.
I don't just throw it in there. Oh, I need a type system. Oh, yeah, Hindley-Milner or whatever. No. I want to understand, why is it there?
Yep.
And does it really need to be there?
And a real programmer is going to benefit from it.
And so that was the case in C#, and that drove a lot of our decisions. For example, we added properties as a first-class language construct because everyone was doing properties. I mean, it was like that was how programs were written. And Java didn't have those, for example. So there were pragmatic decisions that we made. So whenever someone goes, why is this feature there? It's not just because I thought it was fun. It's because it solves this, and this problem.
Right.
And ideally, with every language feature, this is something you come to learn over time, is people will request a lot of features, but they will always have synthesized their idea of what it is that they want. They really come to you with an instance of a class of problems.
Right.
And they tell you, I need this instance.
Yeah. So the trick is to get them to really describe the problem.
No, the trick is for you to understand what is the class of problem.
Gotcha.
And that's what you go implement.
Yep.
So I never wanted to implement a language feature unless I could see multiple good uses for it. We're not just going to implement because it does this one little corner of XML well, and that's it. Do you know what I mean?
Yep.
No, I want this to be a generally useful thing that you can do other things with as well.
Yep, because it's a very serious thing to bake something into a language.
The thing you come to learn about languages is you can add all you want, but you can never take anything away, at least if you care about backwards compatibility.
Yep.
And we've seen lots of train wrecks where people did not care, like, say, the transition from Python 2 to 3. Even when you're just doing it in the name of cleaning up stuff that isn't right and isn't ideal or whatever, you can't do that to your user base.
Yes.
They have too much of an investment. It is your responsibility to ensure that their code continues to compile and work, and then you can add more on top. And if you're not going to do that, then you might as well blow it all up and go create a whole new thing that advances the state of the art. Do you know what I mean?
Yeah.
The worst thing you can do is the 99% compatible thing. That is like absolutely the worst thing.
So some of that attachment to the old is emotional, but you can very quickly have hundreds of millions of lines of code like across.
If you're serving enterprise, well, it doesn't even matter enterprise. It's like anyone who writes a large body of code that then gets adopted somewhere does not want to have to spend a bunch of time changing it in random ways just so it's prettier. Do you know what I mean? No, big code bases get ugly. They all do. And programming languages do too, in a sense. I sometimes joke that show me the perfect programming language and I'll show you a language with no users, because only then can you go change it.
I did an internship at Cray Research when I was a younger engineer, still in grad school. One of the most mind-blowing things that I had ever heard up to that point was I was sitting at lunch one day. One of these Cray veteran engineers was describing the sales process. So they were trying to sell a supercomputer at some point to a car manufacturer. Mm-hmm. And because they had this big Fortran code base that was doing finite element analysis so they could simulate crashes on these supercomputers, they come out with this sort of fancy new version of Unicode, and it was just going to be impossible for the car company to rewrite their Fortran code base, which was tens and tens of millions of lines of code, to work on this operating system for this new machine. And the guy's looking there, he's like, all right, this machine's millions of dollars, and that's tens of millions of lines of code. The operating system kernel is 25,000 lines of code.
Exactly.
Like, we'll just write a custom operating system for this.
Yeah.
Being able to unpack where the abstraction and complexity is really sort of an interesting skill you have to develop as an engineer.
Yeah, so pragmatism was always sort of a main driver for me, and it continues to be.
What lessons as a language designer or like as a builder of development tools have you learned that you're sort of applying to TypeScript right now?
Well, we touched on a couple of them, right? You really have to respect and value backwards compatibility.
Yep.
Doing language design, it's interesting. There's really, in a sense, two phases to designing a language. There's 1.0, and then there's everything else.
Right.
And with 1.0, it's a green field.
Yep.
You can do whatever you want to do. It's crazy fun, and you can be super inventive. But then from there on out, it becomes a very different discipline, because now it's a game of trying to sneak in new features in a way that does not break backwards compatibility.
Yep.
And that is very different. And also, you got to be very cognizant of, every programming language sort of has a gestalt to it. Like if it's an object-oriented programming language, you can move it towards functional programming, but you can't make it into a functional programming.
Correct.
Like where immutability is first, right?
So you can put iterators in, but
so there are certain things where you just got to go, no, if we do this, that'll just give people two ways of doing the same thing.
Right.
And now there will forever be confusion about which one it is that I'm supposed to use. So we can't do that.
Yep.
So after 1.0, you have to learn when to say no.
Yep.
And save it for the next one, which is hard because there are things you want to do, but this is not the right place to do it. And you could sink the ship if you did. And then I think you learn also to withstand the pressures of marketing. I can't tell you how many mails I have written to defend our decision not to put XML literals into C#. I literally spent a year writing that email every 2 weeks. And Visual Basic did put XML literals. And I was always like, listen, there are so many different ways you can write this markup. If we put it in and XML syncs, then we sync along with it. Do you know what I mean?
Yes.
Can you imagine if we'd had XML literals in C# now? What it would, I mean,
can't even imagine.
And it's sometimes you just gotta like stick to your guns in the face of adversity, right? And go, no, this does not belong here. You know, I understand how with the vantage point of today, it might look like it does belong here, but it doesn't belong here long term, right?
Yeah.
So there are lots of interesting things that you don't realize right up front.
I've always thought that the better designed programming languages were the ones where there was some coherent philosophy that was sort of developer-oriented up front. Perl, which in many ways is I've written a lot of bad Perl code in my time. It's sort of easy to do, and it's my fault, right? Not the language's fault. But it had a lot of good stuff, sure. Like Larry Wall, the creator of Perl, had these sort of philosophical tenets like make the easy things easy and the hard things possible. Yeah. I remember hearing Fred Brooks at one point say one of the best things you can do in language design is figure out the things that you're not going to let people say because that's where mistakes happen. So it's always fascinating to me what these philosophical principles are because there's no one right way to design a programming language.
But there are lots of wrong ways, right? I mean, and I think the one thing that people tend to forget too about programming languages is, well, a couple of things. First of all, it's fascinating to look at how slowly they evolve and how similar the programming languages of today are to the ones we used 50 years ago.
Correct.
It's really quite frightening. Yep. I mean, like Pascal was invented in 1974. I mean, so we're talking, 40-some years here.
Yep.
And it doesn't really look all that different. Okay, we've had a few, object orientation, but then Pascal sort of kind of looks a bit like a functional programming language. It doesn't have pattern matching, it doesn't have lambdas or whatever, but it has some of it, like functions and data being separate. And anyway, so that's one thing you come to realize. I think another one is that it's very easy to focus on one shiny thing that your programming language is going to do, right? But then you always forget about the 90-something other percent that every programming language has to have. And that 90 other something percent keeps getting bigger and bigger now because people need tools. They need IDEs. They need statement completion. They need code navigation. They need blah, blah, blah. And so whenever you're like, I got to have my little DSL-like thingy here just for configuring this thing, wouldn't it be cool? Well, are you going to build an IDE for it? Are you going to build two? Oh, no, they're never going to get big enough for, these programs, right? Well, every configuration file grows up to be its own crappy programming language eventually, right? If you don't watch out. And then they get bigger and bigger and bigger. And now you need tools. And now, and there we are repeating history again, right? I mean,
some of the hardest things that I've had to do as someone leading teams of engineers is to be the bad guy coming in saying, okay, we're not going to use this shiny new language. Right. And it's precisely for that reason. When you're figuring out what development tools you're going to use to empower all of your engineers to build great things, you have to make choices because all of the apparatus that you build around them to support them, what's the build system going to look like when you've got hundreds of millions of lines of code and thousands of engineers? How do you do continuous integration and continuous deployment? What does your testing regime look like? So you build all this automation that sort of sits around the programming language. The engineers can sometimes have this notion in their head. It's like, it can't be that hard. I'll just write my one thing in this and it'll be okay.
Yeah, that can happen to you. Particularly the higher you rise in the engineering ranks and the less code you write, the more possible you think the impossible is, right? I mean, eventually you become an architecture astronaut where surely anything can be done here, right? And look at this diagram. I just drew it for you. Just go make it so, right? No, coding is hard and it continues to be hard and code gets bigger and bigger and bigger, but our brains are not getting any bigger and this is largely a brain exercise. I mean,
So one of the things that I end up talking with fellow engineers about a lot over the past several years is where we are now as a discipline, as a profession, compared to where we were before. And so in some ways, the programming languages, from a language perspective aren't that much different now than they were. But you do have these crazy things like cloud computing and open source software where I can't tell you how many times when I was a young engineer, I re-implemented chain hashing implementation. It's like I could probably still write the code just out of finger memory.
Right.
But like so much of this stuff is accounted for you. So you've got really robust SDKs and like standard class libraries for programming languages. And then you got like all of this infrastructure. What you can sit down in a weekend and write in terms of a internet service application, compile it, press the button and ship it to a cloud and then expose it to the world. It's like crazy.
No,
like
it's phenomenal what's happened there. And I think a lot of it is like open source has done a tremendous amount to shorten the distance between individual programmers and between users of someone implementing a tool and someone using a tool. We're this close. I mean, I feel it on my body every day, right? I sit in the GitHub issue tracker on TypeScript, and I'm talking to the very people who are using it, and if they report a bug, we can have it turned around and have it in the nightly build that evening, right? And it's
great.
Which that used to be a 2-year cycle with our like old proprietary style. So the pace of advance there and iteration is just gone up so much.
And it's also that you're doing it in the open, right? So like so many people are making so much of this stuff available for low or no cost.
Yeah. That is still a strange phenomenon because ultimately someone's got to pay, right? And I don't know where that's going to all land eventually, but I have to say I do love the process of doing it. It's sort of like a return to the things that really matter about programming. I mean, our team, it's not a big team, but it allows us to be craftsmen and it allows us to really just continue to iterate. I was always a great fan of, you don't just build a product and then throw it out there and then you move on to a whole new thing. No, you got to come back and polish it and like iterate on it and make it better. It doesn't get beautiful just out of the box. It gets beautiful over a period of years of constant iteration and care. Do you know what I mean?
Yes.
And that's something that this ecosystem allows us to do at such a phenomenal pace that it's just beautiful. We could have never done what we're doing now with Visual Studio Code and TypeScript in the old proprietary world. It simply would have taken 100 years to get that amount of feedback incorporated on the kinds of cycles that we were on back then, right? So that's great.
That's awesome.
Yeah.
And I think maybe that's a good point to stop. We've gone from core memories to, this sort of near infinite rate of change that we've got in open source software. So thank you so much.
My
Anders.
pleasure. It was
this
great.
Is awesome. Such fun.
Fun talk. Yeah.
Thanks for joining me for Behind the Tech. It was a lot of fun speaking with Anders. And, I had some surprises in there. Like, I didn't realize that he had written a precursor to Turbo Pascal while he was still in university. That may very well be the first integrated development environment in the entire world. And, he's so modest about it. Like, I never thought of it. It's like, God almighty. This is one of the more important breakthroughs from the point of view of a developer that has happened in the history of computing. So many thanks to Anders for being on the program. Next time on Behind the Tech, we'll hear from Alice Steinglass, who heads up Code.org. We'll hear about how she's working to make sure every kid has the opportunity to take computer science classes in school. Be sure to tell your friends about our new podcast, Behind the Tech, and to subscribe. See you next time.